Good day to everyone. I appreciate the time that you make to watch this video as I'll be sharing about project collaboration between AIMST University and Keysight Technologies. Well, before getting started, I would like to introduce myself first. My name is Huang Zen Yen. People often call me Zach. Well, I'm one of the final year students in the Faculty of Engineering and Technology in AIMST University. Well, I'm glad that I pursue my degree in AIMST. The reason why is because the green and peaceful campus that provides a perfect environment to study in. Being away from the city life really helped me to focus on my exam and do the best I can in my degree. Now, in this 4 short years of my degree life, I had wonderful experience in AIMST where I get to participate in various events, such as hosting food fairs, concerts, performance, as well as sporting events organized by our student council. The people here have always been friendly, and I've developed plenty of close-knit friendships. As such, one of the photos shown in the slides. Now, as part of my degree, as part of my final year, I am very grateful that I was given an opportunity to take up an industrial-based project. After completing my internship with Keysight Technologies, they offered me a chance to work on one of their projects together with them. So with this, I would like to express my gratitude towards Dr. Hari for being a part of this project as my supervisor and motivating me to take this challenge. This would have been a missed opportunity if it weren't for his dedication towards his students. Now, after a short discussion between Dr. Hari and I, an interesting object about the rectification of 3458A voltage divider effect was decided on. It would be done through the characterization of metal thin film resistor network. Now in this project, what we are dealing with is an 8.5-digit high resolution and precision multimeter. They are significantly used for accurate measurement of electric parameters such as voltage, current, capacitance, and resistance. Now here are some of the features of this model. It is an 8.5-digit resolution, as I mentioned previously. So what it means by 8.5 means that it can measure down to a very small value. Also, it measured with confidence of 8 parts per million in 1 year of DCV accuracy. Now, it has fast measurement speeds up to 100,000 readings per second. Also, it prolonged data logging with up to 148,000 reading memory. Now, in the case of high accuracy and precision instrument, the performance of any passive components such as resistors, capacitors, inductors are vital as they play a very important role in the multimeter's functionality despite being a very small components. Now, the problem behind this project is because of the vulnerability of the formerly used metal thin film resistor network in high humidity condition. Now, in this condition, it will lead the multimeter to present an inaccurate reading for voltage references within the circuit. In this situation, additional problems arises where failure can be detected during the auto calibrations for 10 and 100 millivolts upon range of 1 kilo to 20 kilohertz of the multimeter. Also, there are short-term drifts existing between each reading during the test measurement of the multimeter. Now we can see that all of these problems happen due to the incompatibility of its component coating, or you could say that it's the problem of the internal design flaws of the resistor network. Therefore, a solution was proposed to replace the former resistor with another one that is hermetically sealed, which we believe could potentially help to overcome the humidity issue. Now, a qualification procedure is necessary to be carried out for both latter and former resistor, or what they call RP7, which are taken respectively uh, from two subdivision manufacturer, namely V-Shape and V-Shape Precision Group. So this qualification process includes the characterizing, includes of characterizing the important parameters of the resistor, such as um, nominal value for long and short-term high voltage drift, temperature coefficient of the resistor and its tracking ratio, voltage coefficient and its ratio tracking, as well as the tolerance of the resistor. Last but not least is the power rating of the resistor. Now, mainly the objective of this project focuses on um, comparing both the resistor electrical test performance. Now, through certain test design and measurements conducted to characterize the resistor, it will help to differentiate the performance among them, which later serve as a validating description for the replacement of the former resistor. Now, the manufactured datasheet of the resistor will be used as a reference guide to verify on the test results during the analyzing process. Now, the testing and measuring process will be carried out on Keysight grounds, provided with appropriate labs and temperature chambers help to deliver a more precise and accurate results. Once again, I would like to express how thankful I am as this is the first time that Keysight has ever offered project collaboration with AIMST University. It has been a pleasant learning experience to be part of their team during my internship with Keysight. The people there are truly knowledgeable and quick in solving critical problems. They have always been extremely patient with newcomers such as myself and other interns who are still trying to find their place in the world of engineering. Nonetheless, I would like to take a moment here to say that I am glad to be part of the AIMST engineering family. They have always been trying to equip their students with vast knowledge from theoretical and practical perspectives. Most of the lecturer materials prepared by the lecturers are comprehensive and effective in delivering information to the students. I personally think that they have set the bar for most of the academic institutions to emulate. Now, I found myself very lucky enough to be here among them, as they truly have taken good care of their students, not only from an education point of view, but also emotionally as well as financially through proper consultation. I believe through this project collaboration between industrial and academic institution, both parties will benefit greatly. The students' hard and soft skills can be nurtured, which in turn could produce more capable graduates to contribute to their workforce in the future. Now, I believe most of us understands the differences between hard skills and soft skills. So hard skills is basically more of a rule base about how technical you are and the procedure that you have to follow. As for soft skills, are more towards experience based. How do you manage your time? How are you supposed to communicate? How do you communicate with your team members and how do you behave? Now, I do not want to take more of your time. I hope that this video could inspire and encourage students from AIMST University in reaching out for more project collaborations like this, no matter which faculty they are from. To all students from AIMST, let us show the best in what we can do and carry out our university names with pride. Thank you for watching this video and goodbye.